rich journey of the host institution, that is JP University of Information Technology, that is in Solan, Himachal Pradesh, India, and the partner institution, that is the Indian Geotechnical Society, Shimla chapter.
Drive through the population-free lush green slopes of Vagnakat Solan to reach functionality and aesthetically spread 25 acres of easy-flowing and community-friendly landscape. Welcome to JP University of Information Technology, Vagnakat Solan. Set up in 2002 under the Extraordinary Gazette Notification of Government of Himachal Pradesh. This is the only private university in the state whose chancellor is the governor of Himachal Pradesh. With 108 professors, most of whom are PhD from reputed universities around the world, JUIT offers BTech, MTech, MSc, PhD in computer science, IT electronics and communication engineering, bioinformatics, biotechnology, and civil engineering, whose curriculum is supplemented by SWAYAM and PTEL. A home to almost 2,000 students, this university is twice accredited by NAAC. The world-class state-of-the-art infrastructure of JUIT has 57 labs, including Virtual Lab, eYentra Lab, IoT, lecture theaters, classrooms, tutorial rooms, laboratories, vast auditorium, administrative and faculty offices, an enormous library, and 6 well-equipped gyms. The campus is designed with a vision of creating a university of international repute and highest global standards. Fully equipped with learning tools and web-based educational environment, the campus is planned for the advanced computing infrastructure. Facilities like bank, temple, and helipad are all within the campus. JUIT takes pride in being a member to IEEE chapter and Computer Society of India chapter. It also conducts student exchange programs with the University of Nebraska, Omaha, and University of Florida, USA. To give an experience of the real corporate world and understand the challenges that lies ahead, our students also get an opportunity to connect with industry professionals and self-made entrepreneur. Our exclusive placement cell has an excellent placement record. All this has brought us several accolades. We're ranked among the top 100 engineering institutes by NIRF, MHRD. We've been declared Best Private University of Himachal Pradesh by Dialogue India in 2018 for academics and infrastructure. We're also ranked first under category of value for money and third under the category of top private university in 2018 for offering value for money education by India Today. With a hygienic mess named Annapurna, well-furnished hostels with single and double rooms, mechanized laundry, 24/7 water supply, complete power backup, and Wi-Fi connectivity, we ensure that students feel at home while they're away from home. The overall growth in personality and confidence is taken care by conduct of debates, declamation contests, and a host of indoor and outdoor games. NCC Wing for Girls, and a vibrant youth club that organizes popular sports festival called Padakram, literally festival and cultural festival, which further heightens their energy levels. They're also encouraged to develop independence in thought and action, as well as trained to deploy appropriate technology paradigms for given tasks, explore new horizons, and lead teams to solve complex problems. With our learner-centric educational process, students are free to find their own paths and learn their way to limitless opportunities that awaits them. So be a part of JP University of Information Technology, Vagnakat, Himachal Pradesh, to be the leaders in innovation, entrepreneurship, creativity, and management. because this is where we engineer lifelong learners.
The Indian Geotechnical Society, which was earlier known and founded under the name of the Indian National Society of Soil Mechanics and Foundation Engineering, was established in 1948. This came soon after the Second International Conference on Soil Mechanics and Foundation Engineering held in Rotterdam. The society was affiliated to the International Society in the same year, and since then it has strived to fulfill and promote the objectives of the International Society. The name Indian Geotechnical Society was adopted in 1970. The vision of the founding president, Mr. Khosla, and the honorary secretary, Dr. N.D. Gulati, was to build the society to promote cooperation amongst engineers and scientists for the advancement and dissemination of knowledge in the fields of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, snow and ice mechanics, and allied fields and their practical applications. As the geotechnical community started to grow, the International Society decided to have regional conferences for each continent, along with having 4 yearly international conferences. This is when the first Asian Regional Conference was held in 1960 in New Delhi. India also hosted the 5th Asian Regional Conference at Bangalore in 1975 and the 13th one at Kolkata in 2007. IGS has been organizing national conferences annually in different cities since 1961. The Silver Jubilee Conference was held at Kurukshetra in 1973. 1978's GeoCon was a landmark conference held at IIT Delhi, which was inaugurated by the then Prime Minister Morarji Desai. IGS started the prestigious annual lecture in 1978. A tradition followed till date. The first one was delivered by Professor R.K. Katti. Several others who delivered the annual lectures include Professor Dinesh Mohan, Professor T. Ramamurthy, Dr. R.K. Bhandari, Professor Gopal Ranjan, Dr. B.G. Rao, Dr. N.V. Nayak, Professor G.V. Rao, Professor A.V. Shroff, and most recently, Professor M.N. Viladkar. IGS made an impressive debut in the international scene in 1994 with the organization of the 13th International Conference on Soil Mechanics and Geotechnical Engineering that was held in New Delhi. This was one of the biggest conferences in the history of the International Society, and it firmly put India on the international map.
24 years ago, in 1994, the Indian Geotechnical Society organized the 13th International Conference on Soil Mechanics and Foundation Engineering in New Delhi. This conference was a great success. Everything went perfectly as planned. Its technical sessions, its exhibition, its field trips, its delegate interaction, its companions program, its entertainment, and hospitality. Dr. Parry, the Secretary General of the International Society, in his concluding remarks, branded the conference as the Magic Carpet Conference.
The turning point came from the 12th Annual Regional Conference in Singapore, which saw more than 20 Indian participants and the keynote lecture by Professor Madhav. We were successful in winning the next ARC at Kolkata and also Professor Madhav as Vice Presidentship for Asia for the term 2005 to 2009.
The major visible contributions from Indian Geotech Society have been in the latest 21st century. A large contingent had attended the Singapore Asian Regional Conference. followed by election of President Markov as the next Vice President for the term 2005-2009. Several of our members have been members of IGS have been members of the technical committee, and the most recent achievement of our society has been the keynote lecture or plenary lecture given by Professor Babu at the Seoul International Conference. With the kind of enthusiasm and activities of the Indian Geotechnical Society and its members, I look forward to a much more greater role for IGS in the international community.
The Golden Jubilee Conference was held in 1998 at Delhi. IGC has hosted the council meeting of ISSMGE at Bangalore and the 6th Asian Young Geotechnical Engineers Conference very successfully thanks to great efforts by Professor Sitaram, Professor Srinivas Murthy and the team. IGS was successful in bidding for the 6th International Conference on Environmental Geotechniques to Delhi in 2010, which was a great success with due to Professor Manoj Datta's great efforts. The international community has become aware of our true potential, with several of our members becoming active in several technical committees of ISSMGE. IGS has a full-fledged office in New Delhi catering to the needs of its members. IGS publishes a quarterly journal since 1962. It is now accessible online to all IGS members free of cost. Since 2012, the journal is being published by Springer for qualitative improvement and international reach. It has wide circulation and is retrieved internationally. IGS also publishes a quarterly newsletter to keep its members abreast of all geotechnical events. IGS operates through its local chapters that keeps its flag high in different cities of India. With 44 active chapters, IGS has spread its reach to every part of the country. Some of the active local chapters include Delhi, Roorkee, Mumbai, Indore, Pune, Goa, Surat, Bangalore, Chennai, Kolkata, Guwahati, and several others. To encourage the chapters, an annual Best Chapter Award was instituted in 1995. The Delhi chapter has won this award a record 5 times. The geotechnical industry in India is incomplete without its partnerships with geologists, earth retention system contractors, consultants, and public sector organizations. Institutions like the IITs, CSMRS, CRRI, CBRI provide industry-academia interaction so that the benefits of research reaches the industry and the industry can input to the academia what the thrust of the research should be. This helps in directly applying the findings of the research on the ground for real implementation. With the growing demand for land, we have skyscrapers sprouting up in every big and small city in India. As industries grow, demand for power and power plants also increases. Connecting the industries through bridges, highways, railways, and metros, the Indian geotechnical landscape only shows a promising future. This also means that there is a demand for quality work as the margin for error is nil. Today, IGS is working towards setting up a joint assessment for testing soils along with the National Accreditation Board for Laboratories, the NABL, to match the quality of testing with the international standards. IGS is also working with the Bureau of Indian Standards to prepare Indian standard codes in several aspects of foundation design and field and laboratory testing. Many of our members serve in these committees.
The future is very bright and full of optimism. A number of initiatives have been taken up, promotion of student chapters in various colleges and institutes to sensitize the students about the importance of geotechnical engineering in the curriculum and the practice. Creation of number of professional groups to make them aware of the future challenges and opportunities in geotechnical engineering. A number of initiatives such as interactions with other professional groups that are overlapping with geotechnical practice are also initiated. It's hoped that with all these initiatives and further initiatives that one can have at IGS level, there could be better geotechnics in the country, which ultimately to better, cleaner, sustainable societies.
The future of geotechnical engineering lies in the hands of today's students. Recognizing this, IGS has set up student chapters in some cities, several more in the offing. As we celebrate the 70th year of the Indian Geotechnical Society, the possibilities that we look forward to are limitless. Here's to saluting the past, celebrating the present, and welcoming the future.
Thank you. On this note, a very good morning to all of you once again. I, Dr. Saurabh Rawat, welcome you all to the second day of the first International Conference on Construction Materials and Environment. It is indeed an honor to welcome our esteemed keynote speakers, Professor Krishna Reddy from University of Illinois, Chicago, USA, who has taken his time out and he is helping us and cooperating with us late night and agreed to and accepted our invitation for the keynote speaker. And also Mr. Vikas Malhotra, who is the General Manager of JK Cements Limited India. He is also the head of the technical services. ICCME, the first day, has been an experience of great learning. We have had some very interesting topics, very knowledgeable sessions, and some apt and very knowledgeable sessions regarding the keynotes. Today, the second day of ICCME, will be seeing two keynote speakers, namely Professor Krishna Reddy and Mr. Vikas Malhotra. Before I pass on the mic to our keynote, I would like to take you to the brief journey of day one of ICCME. The day one, that is on June 3rd, 2021, we had three keynote sessions, which was inaugurated by Dr. Sanjay Kumar Shukla from Edith Cowan University, Perth, Australia. He was also our chief guest. The second keynote, which was by Professor Gabriel Chiaro, he was from University of Canterbury, New Zealand. The third keynote, which was followed in the evening at around 5 p.m. Indian Standard Time, that was by Dr. M.V. Reddy from Institute of Research, Hydro-Quebec, Quebec, Canada. We conducted three parallel sessions on different tracks such as Advanced Material and Methods in Structural Engineering, had sessions 1 and 2. And then the third session, which was on track 2, mainly concerned with geotechniques and geo-environment sustainable materials. We covered around 44 papers for discussion and presentation. ICCME Day 2 will be marked with 3 more parallel sessions on 3 different tracks, mainly the advanced materials and structural and methods in structural engineering. The track 3 will be bio-inspired engineering materials, and there will be one more track which will be dealing with recent developments in transportation engineering and urban planning. Here also today we are planning to cover up around 39 deliberations and discussions on researches related to construction material and sustainable environment. The entire technical session will be consisting of about 225 minutes, and then eventually ICCME will be ending off with the valedictory function that will be starting at around 5 p.m. Indian Standard Time. Without taking much of your time, I would now like to request Professor Dr. Ashok Kumar Gupta, who is the Dean Academics and Research and also the General Principal Chair of ICCME 2021, to say a few words and welcome the keynote speakers. Over to you, Professor.
Honorable Professor Reddy, Dr. Saurabh Rawat, dear participants, it's a great pleasure that Reddy sir has accepted our invitation. He is a renowned speaker. I was listening to him when he was at recently at NIT Jalandhar, and at so many lectures. His lecture series is going on online on Saturday or Sunday sometime. I am listening to them also. So it is a great pleasure for us that he accepted our invitation and given his time. Thank you so much, sir. Now it is up to you so much. Thank you so much.
Thank you, sir. Thank you for your kind words.
Thank you.
Before we start with the keynote, I would like to introduce you to the second international conference that is going to be held in November 2021. For that, Dr. Tanmay will take over and he will further elaborate you regarding the conference. Over to you, Dr. Tanmay.
Thank you so much, Dr. Rawat. So it's a great pleasure for me to introduce all of you to our next endeavor in the international conference series, which we are doing at Civil Engineering Department, JP University. So for our next conference, that will also be held in virtual mode due to the pandemic, due to the uncertainties. We are doing it in virtual mode, and it's already in progress. We have already accepted more than 250 abstracts, but due to again and again so many requests are coming, we will revise the last date of abstract submission from 30th April to up till 15th June. So those whosoever are interested, and they are very welcome to put their abstracts and put their research in this conference, which will be majorly focusing on structures, materials, and construction. We have our partner institutes as IGS-SHIMLA chapter, and then Atreya Institute from Bangalore. We have Institute of Civil Engineers with us. We have Institution of Engineers Shimla chapter, and we have IGBC, Indian Green Building Council Chandigarh chapter with us for this conference. The lecture series Spinger Notes, the Scopus book chapter will be published for the selected articles from the conference, and our main keynote lecture will be from Dr. Kong Kian Hao from NUS Singapore. Thank you so much, Dr. Rawat, for giving me the opportunity to talk to the audience. Over to you.
Thank you, sir. We wish you best of luck for your upcoming conference.
Thank you.
So, without further ado, we will be starting with our first keynote lecture for day 2 of ICCME 2021. Before I introduce our keynote speaker, I would like to lay down the instruction for the audience to keep their audios and cameras off during the keynote lecture in order to avoid any disturbances. If they have any questions or any queries, they can type that into the virtual chat box, and I will definitely take them up to the keynote speaker after the keynote session. Our keynote speaker for today, Dr. Krishna Reddy, is a university scholar, distinguished researcher and professor of civil and environmental engineering, director of Sustainable Engineering Research Laboratory, and director of the Geotechnical and Geoenvironmental Engineering Laboratory at University of Illinois, Chicago, USA. Dr. Reddy received his PhD in civil engineering from the Illinois Institute of Technology, Chicago, USA. He received gold medals for being first in BE Civil Engineering from Osmania University, Hyderabad, and ME Civil Engineering in Geotechnical Engineering from Indian Institute of Technology, Roorkee. Prior to joining the University of Illinois, Dr. Reddy worked as civil engineer and project manager for over 3 years in industry and worked on many civil and environmental projects. Dr. Reddy is a registered professional civil engineer and an Envision sustainability professional. He has over 25 years of teaching, research, and consulting experience with special focus on geotechnical investigation and infrastructure, environmental pollution control, and remediation technologies, waste management, and beneficial reuse, and sustainable resilient engineering. Dr. Reddy is the author of 4 major books, including 2 widely used textbooks, the first one being Geoenvironmental Engineering, which mainly deals with site remediation, waste containment, and emerging waste waste management technologies. And the second one is Sustainable Engineering, that deals with the drivers, the metrics, tools, and the applications. He is also author of 256 journal papers, 21 edited books, conference proceedings, 22 book chapters, and 226 full conference papers, with H index of 64 and number of citations over 13,000. Dr. Reddy has given over 200 invited presentations in USA and 20 other countries. Dr. Reddy has served or currently serves as an associate editor or editorial board member of over 10 different journals. He has also received on various he has also served on various professional committees of the American Society of Civil Engineers, that is ASCE, and International Society for Soil Mechanics and Geotechnical Engineering, that is ICCME. Dr. Reddy has received several awards for excellence in research and teaching, including the ASCE Wesley W. Honor Award, the ASTM Hogan Togler Award, the UIC Distinguished Research Award, University of Illinois Scholar Award, and University of Illinois Award for Excellence in Teaching. He is a fellow of the American Society of Civil Engineers, a diplomat of geotechnical engineering, and a board-certified environmental engineer. I really feel honored, and it gives me immense pleasure to call upon Professor Reddy to deliver his keynote. Over to you, Professor.
Thank you very much, Saurabh, for that introduction. I need your help to see how I can share my screen. So I'm not familiar with this platform. I'm very familiar with the Zoom platform.
No problem.
So this share and your entire screen or your window?
You can share your window also. Just try and share through your window.
Okay, let's just see. All right. Oh, in window is not showing what I have. Entire screen. No, I should have my presentation open, right?
Yes, sir.
My presentation is open. Yeah, no. Okay, can you see it?
Not yet, sir. Yes, sir, it's loading. Yes, sir, it's good to go. You can just maximize.
Okay, let's see that. Let's show you a slideshow. The beginning. Can you see it, or?
We can see the slides, but so you need to just maximize it. It's coming in that presentation mode. You can do the slideshow.
Yeah, I did that one on my computer. I can see it.
Okay, maybe it's taking time here.
I had the same problem last time, I think. So should I share the? I shared the window and then I clicked on my file, right?
Yes, sir. Yes.
It's not coming on your screen. So let me stop sharing.
So we can try it again.
Okay, let me just see it again.
Professor Krishna Reddy here. So we can share full computer so that we can see your full screen.
Entire screen?
Yeah, entire screen. So it was resolved last time, like during your talk at our institute.
I know I have the same problem.
Thank you.
One second. One second.
Yes, sir, it's good to go. Thank you, sir.
All right. I know, as I said, like I'm familiar with the Zoom and not with other platforms, so it's good. Again, thank you very much for your introduction, and thanks everyone for joining. I know it is almost midnight here, 11:30 in the late in the night. So I hope I'm awake to cover this presentation. So it's timing is always a problem, but hopefully it is worth sharing some of our research on this very emerging topic. So the conference focuses on materials. So I thought about, okay, why don't I talk about a material? And I chose this material, biochar. And biochar can be used for many, many applications, but I wanted to just showcase its applications through our research that deals with environmental remediation. So that's kind of the idea of my selecting this topic. So first of all, I want to thank Saurabh Rawat for his invitation. And I want to thank all the administration and organizing and advisory committees for organizing this excellent conference. It's a very timely topic and excellent technical program. And I want to thank my graduate students who have done work on biochar. Several students worked in the past on different projects. So I'm going to showcase some of their work. And I want to thank everyone for joining. So I'm from Chicago, and it's a beautiful place. Last two pictures you see, they are Chicago pictures. So hopefully when the pandemic is over and when you are ready to travel, if you are coming to US, now you have a place to visit. So, just a quick view of my research. I work on environmental remediation projects. I work on waste management and landfill engineering. I work on sustainability and resiliency. And as I said, my master's and PhD was on geotechnical engineering. My undergraduate is in civil engineering. So a lot of my research is on geoenvironmental engineering and sustainability and resiliency. So our work has been summarized in these 4 books and papers that you can access from my lab website. So in our research, we do bench scale testing, large scale lab testing, numerical modeling, and then we also do the field testing. Our whole idea is to understand the fundamentals and develop some robust practical solutions. So this is my lab. We have all kinds of material testing equipment, and all the credit goes to my students. Over years, I worked with many students from different parts of the world. And their hard work is what contributed to my accomplishments. So this biochar, I don't know how many of you have heard about this biochar. Biochar is becoming a very popular research topic these days. I just pulled out just from Web of Science yesterday. Look at the number of publications that are being published. In 2020, there are more than 4,000 publications on this particular topic. You say just biochar, and this number might even increase during this year. And if I combine the topic of biochar and soil, you will still see substantial number of papers just using the Web of Science. If I use Google Scholar, this will be 3 times or even 4 times. So the point I wanted to convey with this is this is the hot topic these days. And who is doing research? It's mostly environmental science, environmental engineering, energy, fuels, chemistry, biotechnologies, and also in the world of green and sustainable technologies too. So, so it's a hot topic. So you want to know, what this is all buzz about, right? What is this material, and you want to know something about it. So I want to give you that idea, what is biochar and how it is produced and what are the properties and what are the typical applications of this material. And then I will go into environmental remediation applications through our research projects. So I saw, that this conference covers a lot of different fields, you have environmental, water resources, geotech, and everything. So hopefully, the topics that I'm covering, would be of interest to the participants that you have with the different, expertise. So I'm going to look at these examples on how biochar has been used. These are all our research projects. And at the end, I will make very important closing comments that you can use them if you are interested in pursuing research in this field. What is biochar? Biochar is basically a solid material that is obtained by thermochemical conversion. Basically, you burn in pyrolysis or in gasification. What you burn is the biomass, any kind of a biodegradable material that you have. You burn that one in this pyrolysis or gasification units, but the only condition is that under oxygen limited conditions. So you want to burn with no oxygen present. So any material you burn in open air, that becomes ash, right? So, but when you burn it with no oxygen present, it becomes a charcoal. So biochar is kind of a fancy word for biochar. Biochar is a fancy word for charcoal. But biochar is specifically used to enhance the biological conditions in soil or other media or other applications. So the bio kind of refers to the features that you can exploit with this material. So basically, you have a biomass, put it in this pyrolysis unit or gasification unit, and you are basically heating up with no oxygen. So you're going to get a bio oil or or syngas. So that's basically you are producing the bioenergy, which is good. From the waste, you are creating the energy. And as a result of this, you're going to get a waste, the so-called biochar or charcoal. But it's not a waste. So it's going to be a very, very useful material for many, many applications. So that's what the focus is. So this pyrolysis, you learn about these things. You can learn more about these things, if you're interested. These are basically, pyrolysis is more controlled units, kilns or retards. You put in your biomass and you heat it up under no oxygen conditions. And there are two ways of doing it. There's a fast pyrolysis and slow pyrolysis. Fast pyrolysis is like high temperature and low residence time. Residence time is like how long you keep your biomass in the unit and at what temperature. So those are the things. So fast pyrolysis is high temperature, low residence time. Slow pyrolysis is low temperature, high residence time. And then gasification is another way of creating the biochar. In this one, you basically have a vessel and you directly heat it up. There is some presence of air, but if you can heat it up with limiting the oxygen, then you're going to get more biochar out of this one. So there are other ways of creating the biochar. You can see in this table, but the slow pyrolysis, fast pyrolysis, and gasifications are the most common types of these thermochemical conversion methods. But depending upon these methods, you're going to get amount of biochar. How much biochar you generate depends upon what method you're using, and also not only the amount of biochar, but how much of carbon content you have in that biochar is also dependent upon this production process. So these are very important. How much biochar and what is the carbon content? Carbon content is the extremely important aspect of biochars. So you can find these pyrolysis units in lab scale ones. So you can just put it in your lab under environmental fluid, and then you can use any biomass you want, and you can heat it up at any temperature, and you can have any residence time, and you can do this one. But this is basically you do this one for research. You create a very small amount of biochar in this one. And a lot of researchers, they use this technique. They create a small few, 100 grams of biochar and do the testing. But the quality of biochar is going to be different if you produce it in a large commercial scale. So this is what happens. You put the material inside, and then you heat it up under no oxygen, and then you're going to get biofuel out of it, and also biogas out of it, and then remaining solid stuff is the biochar. You take that one and do your research on what kind of properties that it has, and what applications that you can use. And commercial units look like this. Therein you can put a lot of material, and you have different temperature conditions and residence time conditions, and then create a biochar. And then you can also have a personal top-lit updraft gasifiers. You can actually create one yourself, and basically it will have concentric cylinders, and you put your biomass inside, and then you circulate the air, and you light at the top, and then what happens is the biomass does not have oxygen or oxygen limitation, so it converts as the charcoal rather than ash. So if you are interested, you can learn about how these personal pellets, they call it, and you don't need a very fancy equipment for this one. You can make yourself with basic stuff that could be available in locally. And this concept is also used for cook stoves. And it's very nice because you are using, let's say, wood instead of burning, and you're getting ash and you're getting a lot of smoke. But if you follow this pyrolysis methodology, then you can get a lot of heat out of it, and then there's no smoke, and then at the end you get charcoal. Charcoal can be used for a lot of other purposes. So a lot of emphasis on using this kind of stoves in developing countries. So a lot of work going on in that field. So when you talk about biomass, what are we talking about, right? So anything biodegradable, literally anything, products, waste, residues. You can think about agricultural residues, corn cobs, corn stover, rice husk, rice hulls, peanut hulls, animal manure, yard waste, animal waste, industrial waste, municipal solid waste, any kind of other byproducts that have organics in it. Literally anything that is organic, it's a waste, right? And this is the best way that waste can be converted into energy. And also you're getting, this biochar, which has a lot of applications. So this is what makes it, this is a sustainable material for sustainable application, and contributes to the sustainability. So these are pictures of, what the biomass looks like. Any junk, organic that you want to get rid of it. This is the best way to, produce the bioenergy and also, create a valuable materials out of this. Excellent. So this is the pictures how it looks like. These are the pictures of your biomass, and then dark black stuff that you see is, what it looks like after pyrolysis. So the problem with biochar is that there is no standard biochar. There's no standard properties, standard composition for this biochar. So the yield, right? How much amount of biochar you produce and what properties that biochar will have will vary drastically depending upon what kind of feedstock you're using and what kind of production process you're using. Are you using the slow pyrolysis or fast pyrolysis, gasification, what temperature? So, these are all the controlling factors that will dictate what the end product is. So you could literally have hundreds or even thousands of different types of biochars possible. So when you read the paper about, biochar, you need to look into the details about what that biochar is all about. You cannot really get the same, results if you try to duplicate on a biochar that you created, which may be different than what the original researchers have used. So beware of, these biochars. That's the, misconception that people have. They think that all biochars are the same, but, biochars can be of many types. So you really need to think about this one seriously if you're working on biochar. So just an example, I'm showing you here effect of feedstock. You use different feedstocks, you get same pyrolysis process, same temperature, same residence time, you get different yields, right? So that's a problem. And if you increase the temperature or decrease the temperature, the amount of yield is going to be different. So that's a another issue. So and when you have these different temperatures, different residence times, the end product that you get as biochar, its properties are going to be quite different. So just as an example, I'm showing you the corn cob is the feedstock, and if it is made at different temperatures, you see, specific surface area is quite different, and percentage carbon is going to be different. So when these are different, the material is completely different. So it's going to behave completely different. So you have to be really, really careful about, how you make the biochar and what are its properties. So first thing that you need to do is, if you are interested in doing the research on biochar, or you want to use the biochar for any applications, is you need to characterize. So in our research, we focused on waste wood as a feedstock, as you see here, waste wood, and also we focused on commercial production, because you can do lab scale generation of biochar, but that's not going to be realistic, because in civil engineering applications we need large quantities, right? So when you want large quantities, you have to go to the commercial plants. So we really didn't want to do anything in the produce in the lab. So we wanted to use the commercial facilities to and obtain our biochar from there. So, but we found out sources where they use pine wood. This is a wood, waste wood as the feedstock, and then we looked at you don't have any control on how they create this biochar, but we got some information from these commercial producers on what the conditions are, and then after they produce the biochar, sometimes they post-treat the biochar. So you have to look at that one also. So these are the biochars from the same waste wood, and they look different in terms of the appearance. So look at this. And also for comparison, I put a granulated activated carbon here so that you can look at how they compare. And then if you want to characterize them, you can follow the standard methods, ASTM methods, to know the physical properties, hydraulic properties, chemical properties. And you can do the SEM imaging, and then you can do more detailed porosity and surface area analysis. And we are all familiar with these things. So you can do the grain size analysis, and the sizes can vary significantly depending upon how the biochar is made. And what I'm trying to show here is the same biomass, right? Waste wood, but these are different commercial producers, and following the different production processes, and you can see the specific gravity being different, and water holding capacity is different, and organic matter content is different, fixed carbon content is different. So you really need to pay attention to these variations. Even though biomass is the same, the production processes are different. So here, the water holding capacity, one of them has 180%, other one has hardly 50%. So hydraulic conductivity, generally they are like more like granular type material. They will have high permeability. You can see, no matter which biochar you're looking at it, hydraulic conductivity is very high. And you can do the SEM images to look at, their morphology, pore structure, and the beauty of these biochars is their internal porosity and porous structure that you can see in these graphs. So that's the one of the major benefits of these biochars. And as you see, you really need to look at what is the water content, what is the volatile matter, what is the ash content, what is the fixed carbon. So what you have to look at is the biochars that have a fixed carbon, more fixed carbon, those tend to be the better biochars. And if you have more ash, like you see, these are ash, those are dangerous. They could have a lot of contaminants, metals and PAHs that a lot of people don't pay attention to. So you really need to, characterize the chemical properties such as pH, ORP, electrical conductivity, zero potential. But more than that, you need to also characterize what kind of toxic metals they have, what kind of toxic organics they have. That's very important because, you don't want to use a toxic material in your application, right? So a lot of times you assume your material is inert, like, if you're using sand or gravel or clay, you're not concerned about these contaminants. But when you're using the biochar, depending upon, the biomass and depending upon these pyrolysis conditions, you're going to, have these contaminants, and you need to characterize those things. So a lot of times, you may use this biochar by mixing with soil in your applications. When you have a soil with certain properties, you add a biochar, in different amounts, let's say 2%, 5%, 10%. Generally we go maximum up to 20%, and you are going to change the characteristics of the soil. For example, organic content is going to increase. On the other hand, biochar is a lighter material, your specific gravity is going to decrease. Water holding capacity is going to increase. So dry density is going to decrease. So you're changing the properties of your soil. And it depends upon which biochar you're using. Again, those properties will change. Geotech people love, characterizing the geotechnical properties of biochar and biochar amended soils. You can do the Atterberg limit test. You can do compaction tests, and you will find some strange results, with these things. And then, when you add it to the soil, you're going to create that internal porosity that you would not have with the soil alone. And hydraulic conductivity, soil may be, if you are dealing with a clay soil, hydraulic conductivity may be low. When you add in this permeable biochar, hydraulic conductivity is going to increase. So you need to really pay attention, for your applications. In case of compressibility, generally a biochar is less compressible than the soil. In terms of the shear strength, surprisingly, the biochar has a higher shear strength, and even if you add this biochar to the soil, the shear strength is going to increase. That's a positive aspect. But moisture content, makes a lot of difference. If you test the dry biochar versus moist biochar, you will get different results. So you will see that generally when you have moisture content, the strength is going to decrease. So you need to have those properties at hand when you think about biochar applications. And there are many biochar applications. In agricultural applications are very common. So they have been used extensively as a soil amendment, in the agricultural fields. That has been going on. But just recently, a lot of attention has been drawn in environmental applications and also in infrastructure engineering material applications. So soil-based stabilization, you can add even into concrete. You can think about anything that you want to do with this material. But the applications depend upon matching your application needs with the composition and properties of biochar. So biochar agriculture application is very straightforward. You just basically go to the field, you add your biochar to the soil and grow your crop regular way. And then at the end, you will see that depending upon the biochar that you use, your crop yield is going to improve. This has been going on, and the farmers love it. So the major applications of biochar so far has been in farming. But as I said, this material being unique with a high internal porosity, a lot of people are starting looking into these environmental applications and infrastructure applications. So we have been working on this one for many years. We did some projects on nutrient removal from wastewater and the stormwater treatment, contaminated soil remediation, fugitive land gas emissions. And all these, applications become sustainable because you are using the biochar, which is a sustainable material. You're doing the waste reduction, conservation of, resources, pollution control, all those benefits you are getting it. So truly, whatever you do, with biochar eventually should lead into a sustainable solution. So I want to show you just brief glimpse of these research results. I'm not going to go into details of this, but hopefully you can get more information from the publications that I have. So there are many studies that you can look in the literature that look at biochar, using the biochar to remove the nutrients and other types of contaminants from wastewaters, and by using biochar as the adsorbent. I want to show you this one. Ammonium is the one that people want to take it out, and depending upon the biochar, you can take out different amounts of ammonium. So the activated carbon is not doing good job, but your biochar is doing good job. That's the advantage of this. And phosphate, it's hard to take it out, that one, but you can find the biochars that can do it. So don't give up. If you have a biochar and that does not work, it doesn't mean that you could not think about another biochar that could do this thing. So you have a lot of flexibility because you can create a lot of different types of biochars, and hopefully one of them will work. So if it works, then you need to look at the kinetics, how much time it takes to uptake the contamination, and also what is the maximum capacity that it can take. So these are the things that people have looked at it. And our project is kind of interesting. I had a student from China, and he is interested in looking at the biochar, and we created this project for him. So why don't we use the biochar to remove the nitrogen, phosphorus, and potassium? These are kind of nutrients that you find in the wastewaters. And then phosphorus is the one which is hard to take it out by the biochar. And we wanted to add MgO, magnesium oxide, that combines with phosphate and forms the struvite. So we wanted to look at combination of biochar to remove these other nutrients, and for phosphorus, maybe we can use this MgO. And maybe once you do that one, and you have this material that absorbing all these nutrients, and why don't we take that one and then spread that one in the farm fields? Now you are using this biochar with a lot of these nutrients, and you're going to get large amount of crop if you use this situation. So that's what we wanted to see if this is feasible or not, because if you use the biochar just like that, you can get some benefit, but not as much benefit. By doing this one, you are removing the contamination from the wastewater, you're cleaning up the wastewater, and also you are using the biochar with nutrients in farm fields that can give you huge yields. So this is the in lab we use the synthetic wastewater. We looked at different types of biochars that I mentioned before. These are all wood-based biochars, and we looked at the magnesium oxide to form the struvite. I don't have time to go into the chemistry of this struvite precipitation, but if you can add magnesium oxide, and then you have these reactions, you form this precipitate. Our experimental procedure is very simple. So basically, you take the wastewater and add some biochar and mix it, and then take the solution and then see how much of contamination is reduced. Because some of the contamination gets absorbed onto the biochar, you will have a less amount in the solution, and then we analyze that one, how much is in the solution, how much reduction that you have. And so when we want to add magnesium oxide, we do the same thing. We add biochar and we add magnesium oxide and look at how much is the concentration. So here are the results. If you look at these results with the magnesium oxide alone, you can take out the phosphorus, but nutrient you need the biochar. And you can optimize, again, based on these results, the biochar BS and BS plus MgO, are found to be very efficient in taking out both nitrogen and phosphorus. And then you can optimize what should be the ratio of biochar and magnesium oxide, because we are going to use both of them. So in what proportion that you need to use, so that can be optimized. And then once you optimize that one, okay, that's the one which we're going to use it to clean up the wastewater. And then can we use it for agricultural purposes? So we did this pot test, adding that biochar with those nutrients taken out from wastewater. You look at this one. So these plants love it, and we got the best results. So you're achieving two things with one project. The stormwater in cities is a huge problem. When you have a rainwater, when it rains, all the contamination from the roads and everything, goes into, these waterways. And in Chicago, we have this lake, and all the contaminated surface runoff goes into this lake and contaminates the lake. So this surface runoff can have a lot of different types of contaminants. So the idea is, can we have a in-ground filter system that water can go into this filter, and then you have a clean water that can be discharged into the lake. So in this case, what kind of filter media that you need to use? So our question was, can we use the biochar as a filter media? So we tested this one on a synthetic stormwater that contains nutrients, metals, PAHs, and even biological contamination, E. coli. And then, based on, how do we do this? Basically, we do the column experiments, and column experiments kind of simulate the filter response. And then we can look at this, and what is, you know how much you are putting in, what is coming out. Based on that, you can calculate, how much of the contamination is being removed. So you can look at it, it can remove a lot of different contaminants, and which is really good. And among the metals, some of them are removed, more, some of them less, but, the removal efficiency of this biochar is very substantial, which is really good for using as a filter material. In case of remediation of the soils, one of the techniques we use is the phytoremediation, basically grow the plants so the plants can uptake the contamination from the soil. They can stabilize the contamination within the soil in the root zone. But, it does not work. Sometimes the plants don't even grow because the soil or fill material may not have enough organic matter. It may not have moisture. It may not have nutrients. Or if the contaminant level is too high, it is toxic to the plants, and plants don't grow. So our research was to see if we can use any amendments to the soil that can solve these problems. Out of all these different amendments, I'm just showing the results of biochar. And biochar has a nice water holding capacity, nice nutrient capacity. And then we did the test, pot test. And then we found out that biochar can actually create the conditions favorable. For example, here, these are different conditions. We looked at it, but I want you to focus on T2, T3. T2 is without amendment, and T3 is with biochar amendment. Here is the percent germination. For one plant, there was not much difference, but for the other one, sunflower, you look at that one. If you don't amend it, germination rate is low, but if you amend with biochar, germination rate increases. So survival, once germination happens, what about the survival? The survival without amendment is low, but with the biochar amendment is high. So you can see the benefits of, this biochar amendment on a lot of things. The plant height, how much is the biomass, and then how much is the exchangeable nutrients that you have, and exchangeable metals. You want to have those reduced. So that's what you see. If you look at the T2 versus T3, and you see generally, there is some reduction in the contamination levels too. T3 reduction is due to some biological activity. So this, biochar is a great material for enhanced biological conditions, and then you can get, reduction in these things. And then last application that I want to show you is this fugitive landfill gas emissions, because, or dumps, the waste degrades, all the gases try to come up. If you have a gas collection system, parts of it gets collected, but parts gets released. And if you don't have any gas collection system, like in India, you have dump sites, all the gases are coming up into the atmosphere. So even if you put a soil cover, there may be some methane oxidation due to the bacteria that you have in the soil. That's really good. And methane is, that is the greenhouse gas, and the reduction of it is very important. Now the question is, since the soil does not, oxidize too much of methane, can we add biochar to the soil to improve that methane oxidation? Why biochar is important? Because it has high internal porosity, it has water holding capacity, it has nutrient capacity. It is a stable source of carbon. The carbon that you have in the biochar, people found out that it can last for thousands of years. Nobody knows how long it's going to last. But not like compost. Compost can degrade really fast. and it can absorb the methane, and also it can, because of all these factors, and also it can really create a nice environment for microbes to reside. So we have been doing the research on this one to characterize how much benefit that we get by adding the biochar. We do a lot of batch tests, we do a lot of column tests, and with a lot of tests that we have done, we have shown that biochar actually helps. It will, enhances the methane oxidation. Basically, we are trying to add 2% or 10% to the soil, and that can change dramatically the oxidation rates. In the column test, we simulate, creating the column, and we put the biochar amended soil, and then, test it. And we find that, again, the biochar amended soil has an excellent methane oxidation potential. And, why is it this? Because a lot of it is, it absorbs the methane. Not only that, in the long run, it provides, this biochar will provide a nice environment for microbes to, thrive in biochar micropores. And then you can see a lot of microbial activity as a result of this. And we have also done field testing, to demonstrate how it works in the field situation also. Again, a lot of these results takes time to explain, but the idea is that biochar can be used for beneficial application for all kinds of these things. So our ongoing project not only looks at methane conversion into CO2, but even sequestering the CO2 or H2S gases using the slag layer on the top. Basically, we have zero emissions coming out from landfill. So you could do simple things like this one on dump sites where you have a lot of H2S, all the odors that you have. You can go there and put a biochar amended some soil layer. Even a thin layer will solve the problem. So I know I am taking too much time, so I want to end with the last slide here. So in the closing comments, what are the takeaways from my presentation? So if you are interested, and as I said, I showed you, a lot of people are working all over the world on this biochar. Biochar is a stable carbon material produced from biomass. It's a waste, right? And during bioenergy production, so you want to have alternate energy, right? So bioenergy is, good sustainable way to have alternate energy. So it's all leading to good things. So the material biochar is a sustainable material. But I want to, I cannot overemphasize the importance of realizing the fact that not all biochars are the same. When you read a paper, a lot of times they talk about, this paper title is biochar, biochar, biochar. But what is that biochar that they are dealing with, right? So you really need to look at it. Because the properties of the biochar vary, depending upon the feedstock and pyrolysis and gasification conditions. And also you need to look at, whether they created the biochar in the lab scale, pyrolysis unit. Because again, I told you, if you do the lab scale pyrolysis unit, the quality of the biochar there, that is different than, commercial production. So detailed characterization is very critical. And a lot of times, you may do, geotechnical and physical chemical properties, but one important thing that I want to emphasize is the contamination content. Please, if you work with any of these materials, try to see, if it is a toxic. You don't want to work with a toxic material, even in the lab, right? The dust and other things that could happen. So in our research, we screened, a lot of the different biochars, even, based on the waste wood. And for some of them, we found, really high content of metals and PAHs, and we discarded those things. We are working with only the biochars that are clean, no metals, no PAHs. But, think about this biochar. You really can, innovate and create a biochar that will have properties that you are looking for. So it's it offers such a flexibility. So basically, it needs a lot of trial and errors. What kind of biomass I need, what kind of pyrolysis gasification conditions I need to get biochar that possesses the properties that I'm looking for, and to meet my applications. So you can have infinite applications practically, because you can create the biochar with the conditions that you want. But that, you need a lot of research on that one. So one thing I want to mention here is, if you have a project and you want to use the biochar, this biochar should be available locally, close to the project site. Okay, if it is available, farther away, then the transportation, all the logistics makes it not sustainable. So you should think about, as I told you, that pyrolysis units, you can have a small ones, you can create your own ones, but as long as they are close to the project site, and as long as it does not involve too much of transportation, then it becomes really sustainable. So these are the points I wanted you to take away, and I did show you only the environmental applications through our research, but you can have a lot of other infrastructure material applications. So with that one, these are the publications that we have on biochar over the years that we published, conference papers and journal papers. And if you go to my website, you should be able to find all these papers. If you type biochar as a keyword, you should be able to find all of them. So I just want to, announce that we have a weekly Friday webinar series. As a matter of fact, in India, it's 7:30 p.m. today. So you're going to have a webinar that deals with a lot of different topics on geoenvironmental engineering. So every Friday, 7:30 p.m. in India, if you're free, please join this webinar series. So with that one, I want to give you my contact information. I know I may not be able to answer all your questions, but feel free to, email so that I can respond to your questions. I want to thank you all for patient listening. Thank you so much.
Thank you so much, sir. That was indeed a very great session, and thank you for taking us through the biochar process and its application. We have certain questions from the audience. If you permit, should I start?
Yeah, sure.
There's a question. The participants wants to ask that how the shear strength of biochar amends the shear strength of soil, since the shear strength of soil is higher than the biochar, because the density is getting decreased when you're adding something into it.
Yeah, the density is decreasing, but you really need to look at, what is the interaction with the biochar with the soil is, right? Even though slightly, density is decreasing, the strength does not solely depend upon the density, right? So you could have a lesser density material, you could have still higher shear strength. So it is possible. So just, look at into the details of it. Okay. So it's like, how you have that soil particle to, this biochar particle interaction that takes place, how the friction gets generated, that you have much more, even biochar by itself, its density is very low and it has higher shear strength than soil itself, clay itself.
A similar question related, it says that how the compressibility of soil, which depends on the porosity of soil, how the compressibility of biochar amends the soil since it is lower than the soil alone.
Yeah, I showed you, like we have got some results and we have some papers also published on that one. It's kind of interesting. You need to look at the compressibility behavior of soil, typically well known, but for these biochars, what we found out is, depending upon the stress range, the response is different. So you have certain compression ratio during the first stress range, and then second stress range, and towards the end you don't see any compression whatsoever. So it's like a flat zero. Whereas the soil has, you have a secondary compression that is taking place. So so that's kind of interesting response of the biochar. And again, I want to rethink about what I'm saying about biochar, because the biochar that we used could be exhibiting this way, and then the biochar that you created from that different biomass and different pyrolysis conditions could behave differently. So please do your own testing. Don't rely on the results that are reported by others, because the biochar, I told you, you could have hundreds of different types of biochars. So a lot of times so if you have material varying so much, how do you actually use it in the field? So what I'm proposing is, like, what I try to do is come up with the material specifications. Okay, I don't care about what biomass that you have used, what pyrolysis conditions you use, because we cannot control those things. You cannot see what the commercial vendor is doing or some other people are doing. But we have specifications on the physical properties, chemical properties, contamination levels, and the engineering properties. So if you meet those criteria, okay, I don't want to ask you, how your biochar is made. So the performance requirements, based on that, you should go with it because of so much of uncertainties, or variables that are involved in biochar production.
Thank you, sir. So there's one more question. It says that when dealing with biomaterials, what effect can internal porosity have for geotechnical applications?
So the internal porosity makes a lot of difference, because the surface area is different, and then water holding capacity is different. So if you are dealing with clays, the surface interactions could be different. So you have that lot of internal micropores, they're all going to be filled with water, and or other kind of chemical constituents that you're dealing with it. So what you have in those micropores that makes a lot of difference. So that's what you need to really look into, so that when you add my biochar to the soil, so you're going to create this composite material which has due to the biochar content, you have higher internal porosity. That porosity, what does it mean, is basically the higher surface area, specific surface area. And then what happens if you have high specific surface area for the soils, right? So same thing, so a lot of other physical chemical interactions could come in play, and that could affect your compressibility and other fundamental engineering behavior of your soil.
One participant asks that we use wastewater for irrigation purposes. What can be the possible solution for that? Can we use biochar for the solution of clearing out wastewater, then we use it for irrigation purposes?
Yeah, that one thing is, you have to look at what the wastewater consists of. You don't want this biochar can take out a lot of metals also, so it can take out the contaminants. So I didn't tell you what the wastewater that we are looking at. So the wastewater that we were looking, it didn't have any other toxic, metals or toxic organics. It had only nutrients. Okay, so if you want to use, the biochar for treating, industrial wastewater, then you're going to absorb all the toxic metals onto your biochar. You don't want to take that, biochar that has the toxic metals absorbed on it and put it in the farm fields, because what happens is in the farm fields, when you grow crops, there will be uptake of contamination from the soil, from the biochar into your food chain, and then humans are going to be heavily affected by that. So I would suggest that, okay, what are you absorbing by biochar? So if you have just the nutrients, this is great. You can apply to farm fields without any treatment. But if you have any toxic things, then you have to really worry about it. Is there any way that you can dissolve the toxic elements and then you put them in there? So you really need to look at the environmental issues associated with this.
And there are two similar doubts. Can we use biochar for utilizing red mud and expansive soil stabilization?
Yeah, I mean, there are a lot of papers that they looked at it. They looked at expansive soil swelling reduction. So that there are many different geotechnical applications that you can look at it. So you can look at what biochar is locally available in your area, and you can come up with a research program where you can add biochar in different amounts and do the the swell testing or whatever conventional testing that you're capable of doing to evaluate will that address your expansive soil, or you're dealing with the red mud. What is the problem that you are trying to address? Are you trying to address pH issue, or leachability of the contaminants? So as you know, that pH also depends upon what is the biomass that you're using it. So the ones which we used, they are close to neutral, so they're not going to change the pH of the soils that much, but or red mud that much. But you can use, if you have drastically lower pH for your biochar, and then you can probably add it to red mud, to neutralize the pH. So that's why I'm saying, this biochar world is really huge. Biochar universities. That's what I don't understand. A lot of people don't understand. When you say the biochar, you're talking about a lot of different things, and you cannot extrapolate from the results from one study to other study. So you really need to characterize the biochar that you have access to. That's the first thing. I mean, a lot of work on biochars is done in China. They have a lot of biomass, and I have seen the papers. A lot of papers on cat litter, in the poultry waste. They convert the biochar, and then they're doing research on that. And some of the research is basically just the lab research. As I told you, you can create a pyrolysis unit in the lab and get the kitty cat waste, and then create a small amount of biochar, and then do the testing on that one. So hey, nobody else has done research on biochar from
waste.
So that is a unique contribution of your research. But no, I think you need to be realistic when you are doing this research. That's why I always get concerned about any research that is done on a laboratory generated biochar. Because in construction industry, I mean, on all my applications, I need tons of material.
Exactly.
So where will I get? And my lab is not going to produce that much. So you have to go to the commercial vendor. So you just order the material, and they will deliver it in trucks. And if you did the testing, all your testing based on the lab one, and the one which you get from the commercial vendor is different, so then you're back to square, right? I mean, you really think about whether this is going to work for your application or not. You have to redo the research again with that material that you're going to get it. So there are a lot of opportunities for doing research in this one, and as I mentioned, just the web of science. You have so many papers, and but just try to focus on what you want to do it, and definitely it's worth pursuing research with this material, because it leads to when we're thinking about sustainability, it definitely contributes to the sustainability.
Thank you, sir. I don't think so there are any other questions. Thank you. Excellent session. A very good presentation. So one last question. How are the biochars useful in permeable reactive barriers?
Yeah, permeable reactive barriers. It's same like what I showed you in the.
Yeah, he has written, sir, explain that figure which shown in PPT, something like that.
Yeah, so it's like how I showed you that filtration of the stormwater. So you pass through it, and the contamination gets absorbed. So same thing with the permeable reactive barrier is, for groundwater treatment, you dig a trench and then put the material, and water passes through that, and then contamination gets absorbed onto the material, and then you need to decide on how long it's going to last, and then you need to replace it. So you address all those issues with that one. So definitely, so it's an absorbent. You can use as an absorbent. Generally, it's not reactive material. So just one thing you need to remember, that you are heating up this biomass to 600, 700, 800 degrees centigrade. So everything that gets burnt. So you have very inert material, inert porous material that you have. So how much you can trap into this, porous, structure, is some biochars shown to have some surface charge, but you need to characterize that one. So the ones which have certain charge may be favorable for absorption of certain contaminants, but you can do the characterization of that one. What contaminants that you're dealing with, and then you can do some absorption or absorption test, and then see if the material is useful or not.
I think so. You have one similar question. I think you have already answered it. It says that if you're using biochar in landfills, there are chances of leachate migration into the soil and groundwater. So
yeah, so I always I have problem of somebody creating the liners which has a high absorption capacity, because the liners, you're not supposed to have a lot of absorption there at the bottom, because then one day it's going to release it. So so you don't want to put it in a liner in the bottom of the landfill, which is the absorptive liners is is not a good idea in the long run. Because if it was not absorbed, if you have leachate collection system, you would have taken those out, and then you have treated above ground. Now they're absorbed, and then it cannot come out from the leachate, and then it will be there, and over a long period of time, what happens to the desorption potential? You don't know how the geochemical conditions are going to change, right? pH is going to change. Now they are absorbed now, but in the future, pH might change, and then they may dissolve. So a lot of the geochemistry aspects have to be looked into it.
thank you so much, sir. I think there are no further questions. Once again, I thank you, Professor Reddy, for giving your valuable time. I know it's very late in Chicago, and you have been staying up just for us. And thank you for your cooperation once again.
Yeah, no problem.
It's really an honor. Thank you so much.
No problem. Thanks to be part of this. Thanks for your invitation. Thanks everyone for listening, and so good luck with the rest of the program.
Thank you. Thank you so much.
Thank you.
So, our next keynote lecture is on the topic of, or you can say it is an industrial keynote lecture. That is the second keynote for the second day of ICCME 2021. Once again, I would just like to inform the audience about keeping the audios and cams off during the lecture, and they can type the questions in the question answer box or the virtual text box. Our next speaker is not only a civil engineer, but also a marketing official with over 25 years of techno-marketing experience. Mr. Vikas Malhotra completed his BE in civil engineering from Punjab Engineering College, Punjab University in 1995. In 2011, he obtained his MBA in marketing from University Business School, Punjab University. Currently, Mr. Vikas Malhotra is the General Manager, Technical Services, White Cement Division, JK Cements Limited, India. He has been responsible for launch of new products under the umbrella of JK White. He has launched products named as JK Primer, XX, New Wall Finish, JK Tile Max, Tile Adhesives, JK Level Max, and a ready mix mortar. He is also been looking after the budgeting and planning of promotional and brand building activities of existing as well as new products in the territory of Punjab, Jammu and Kashmir, Haryana, and parts of Himachal Pradesh. Before joining JK Cements Limited India, Mr. Malhotra also served as a regional manager, technical service for Jayaprakash Associates Limited India in the cement division between 2014 to 2017. Mr. Malhotra was also shortlisted and selected in Future Management Cadre for Fast Track. It is a test that is conducted for top 3% of the managers having best consistent outstanding appraisals. He has also played a key role in recruiting, training, grooming, and developing technical teams consisting of 18 members in Punjab and 6 members in Himachal Pradesh and Haryana. He has also played instrumental role in developing all systems and procedures for technical services. Today, technical service team in Punjab has been able to create its niche in the market and has been recognized as an integral part of core marketing teams to establish JP Cements as a brand in competitive Punjab market. He was also responsible for getting JP Cement brand enlisted in all major government departments of Punjab like the PWD, Punjab Irrigation Department, Punjab Urban Planning and Development Authority, Punjab Health Services, Panchayati Raj Punjab. For JK Cements also, he is responsible for execution and control of promotional activities for all segments, that is masons, contractors, project engineers, architects, and networks. With these words, I would like to invite Mr. Vikas to kindly take over the virtual podium for his keynote on the topic cement-based value-added products. Over to you, sir.
Thank you, Saurabh, for a very warm welcome and nice introduction. It's my pleasure to be part of this conference. And as you have said that the title or the topic of today's discussions is value-added cement-based products. Before actually going into the detail of the products, I would like to, because this will be something new for most of us who will be on the platform. So just because I believe there are some students, some technocrats, some academicians, so it's a mix of people. So I would like to, share something about my topic before I actually go into the presentation, so that it can create a thought among all of you that what we are and what do we want to discuss. So basically, friends, in one line, if you want to understand what is value-added cement-based products, I would like to highlight over here, you all being civil engineer professionals, and you have been into construction for different periods. All of us might be having different kind of experiences. But whenever you talk of construction, most of the time, right from the foundation till the end of the building, we are doing our construction work with the same cement. I am from a cement industry. Most of my experience is in cement only. I work with different companies. But if you talk of what is being done in the field, it is always the same cement which is being used right from the foundation till the finishing of your building. But that is not the right way. I can give you a very crude example before I started, because each application of cement requires different kind of product, whereas we are using the same cement for all the applications. You just think of cement which we are using to paste our tiles. Tile, you all understand there are various kind of tiles available in market, right from vitrified ceramics to glass tile to a number of wooden tiles are also available. So all those tiles, when you fix them with your cement only, which is the traditional method we have been doing over a number of years. So just think of that, the cement which actually goes in pasting of the tile, the cement which is you are using, the cement slurry which you are using to paste that tile, that doesn't get the opportunity to get cured. That's very obvious because it is covered with the tile itself. So this is one of the example where we need a different product. It has to be a product which should not require any curing. So that is one requirement. There are many such applications. You have been using many cement as a material. Basically, cement is only a binding material. It doesn't have all the properties required for different applications. So that's the concept which I will discuss with you, and we will take it further to introduction of our new product. So not taking much of the time. Saurabh ji, I think I will be able to share my PPT.
Sure, sir. You can see that there is a arrow down below.
Yeah.
Person now.
Just wait.
Yes, sir, it's visible. So you can just go to the
Yeah, just
slideshow
yeah,
mode.
yeah, I will have to. So I hope it is visible to all.
Yes, sir. So you can go to the slideshow mode, sir.
Actually, there is some issue with my laptop yesterday also. So I think it will be comfortable if I continue like this. When I
No
go to
problem.
yeah,
No problem,
because
sir.
when I move to that mode, there is some issue in changing the slide.
Oh,
Anyway,
no
we
problem,
just
sir.
move forward. So as a formality, something has been told about myself. Now I will share something about the company. Then we'll move on to the topic. And this presentation I have made, friends, keeping in account all the people who are at the platform. Those are students also and academicians also. So some basic things will also be there, and some high level things will also be there. And as Saurabh ji has already explained in the last session also, if you have any queries or any questions, you may put down in the chat box. We will take up in the end of session. So not taking much of the time. Uh, Friends, these are just few challenges and opportunities with respect to present scenario. This is very general slide. So we all are facing these things. So we have to be positive in this COVID-19 situation just to break the ice. And now this is all about my presentation. I will start with my little introduction of my company, my products, our product value portfolio, then value added cement based product all description, technical specifications, cost. Now each of the product I will specifically focus on these three areas. What is the description of that product? What it is? Why do we need that product? I have already given you a small background. And what are the technical specifications of that product? And what is the cost is very important. Normally my experience says that as engineers we have good knowledge of these two things, but we are normally not aware of costing. So that's not a right way, because you being a specifier, you being a person who is recommending to use a particular product for a particular application, then certainly the client or whosoever is investing, he will be worried about the cost, how much increase will be there. So for each of my product, I will be touching on the cost part also. My organization, very old organization, running fast because this is just a formality. We are 125 years old, and we have a turnover of around $2 billion. 25,000 employees are there. Now this is how we started in 1920. These were the founder members. How do we got our name? JK. He is Shri Jugilal and he is Kamalapath. J and K. Here we got our name in 1920. The league was followed by all these people, and under the chairmanship of Shri Gaudhari Singhania ji, we got an opportunity to enter into cement market, and that was in 1974. And after that, Shri YP Singhania ji, he himself is a civil engineer from IIT Roorkee, and he was a very dynamic person. He took us to very high levels, and we launched a number of products. We were first to produce white cement in India. Many new products we have given to construction industry. Last year, unfortunately, he left us, and now his nephew, Shri Madhav Singhania ji, he is leading the group. And many awards are in our basket. This is few of them. We are in super brand category. Many awards, as I've told. The company is having world-class cement manufacturing technology. We are in technical collaboration with FL Smith, which is the world leader in cement technology, and that's a Denmark-based company. And we are following all quality standards, all ISO 9001, 14. This is regarding quality management system, and this is regarding environment. We are following all these systems, and this is the spread of my plants. We have plants across India. Started from Rajasthan. This is another plant in Haryana. This is in Katni. This is all in India. We have an international presence also in Dubai, where we are producing both grey and white cement. We are not restricted only to Indian markets. We are exporting our products to a number of countries. These are few of them. Now, this is just a view of my white cement facilities. This is a Fujairah. This is our Dubai plant, and this is Gotan, first plant in India where we produce white cement. This is Katni. This is the plant, friends, where we are producing all our value-added cement-based product. The topic which I am discussing, and this is in Madhya Pradesh, India. Now, before I actually move into the cement-based products, I will give you some facts about cement industry, cement scenario, what we are and how we have evolved over the time. Friends, this is the gentleman who first invented cement. That was on 21st of October 1824. And this was done at a place, Portland. So that's why you have two types of cement mainly in India, OPC and PPC. Ordinary Portland cement and Portland Pozzolana cement. So this Portland word is referring to the place where this gentleman first invented cement. Now this is the scenario as on 2015. Today it is around 3600 million ton is the cement capacity. China is the world leader. We are number 2. But there's a huge gap. We are producing around 400 million. Last year capacity was 400 million ton per annum, whereas the world is at 3600 million ton. So you can very well imagine from this gap that there's a lot of scope in India. So being a civil engineer, you all should be technically ready for that. Now this is a technological shift from our earlier cement plants to new cement plants. Many things have changed. Now this is one short diagram for those of you who are interested to know how cement is manufactured. Since I am from a cement manufacturing company, so in one slide I can tell you this is our limestone, the natural stone which is used to produce cement. We do blasting over here and we reduce it to the size of 40 mm. And then this is our crushed material yard, where this is not only limestone, it of course has some iron ore, it has some magnesia, it has some clay in it. Those all material taken in a particular proportion are then grinded in this ball mill, and then they are fed into this preheater. This preheater is, as the name suggests, the material will be heated in this cyclonic fall, and it will ultimately fall into the kiln. This is a rotary kiln which keeps on rotating at a very small speed, and the temperature inside is around 1450 degrees centigrade, very high. And at this temperature, everything gets melted and it flows like water. And after that, it is passed through coolers. This is coolers where it attains a spherical shape, and we get clinker which is stored in this clinker yard. Now you can see 3 silos over here. This first one is of clinker, second one is of gypsum, and the third one is of fly ash. All 3 taken in a particular proportion are then further grinded into cement. So that's how we get cement, and that is then fed into the market. So this is the entire process which is for cement manufacturing. I call cement as a magic powder, very flexible material. You can cast whatever you want. This slide we have already discussed. Now this is, friends, per capita consumption of cement in various countries. India, we need to do a lot. Even we are even less than half of the world's average per capita consumption. World's per capita consumption is 270 kg. We are at 120 only. So a lot of things will happen in the coming days. These are the figures for China and America respectively. And regarding manufacturing, I have already, these are the actual photographs. You can just have a feel of these are limestone mines. And this is stacker and reclaimer arrangement to mix the material. This is that grinding unit, vertical grinding unit, where we grind all the materials. This is the inner view of that kiln, where the material is melted at 1450 degrees centigrade. And this is that clinker. Now till this place, the cement manufacturing is same for any type of cement, whether it is OPC or PPC. Now this is the place we control everything. And this is our grinding mill where we grind the material. Why I am sharing all this is just to have an idea what cement is and how it is manufactured. So these are the testing equipments being used at the plant. Now coming to the actual topic, I would again repeat today's topic. It can be called as dry mix mortar or value-added cement-based products. It's one and the same thing. Basically, we have been using same cement for all applications, which, as I have told you, the cement being manufactured in, as I have described in the previous slides. So that cement, basically, it has some good properties. The basic property which we are looking in cement is its strength and good binding power. Looking into that, we have extended the use for all kind of applications. It can be laying of bricks, it can be plastering, it can be fixing of tile while construction of my buildings. But each of these applications, we have realized over a period of time, requires a different kind of product. So for that, we have formulated different products under this umbrella branding of Max. You will see each of my product is ending with Max, Prime Max, Shield Max. These are all written in the bottom of these slides. So Max is basically maximum strength and quality, we say. Now, introduction to dry mix motors, as I have already given you a brief. Basically, these are the ready mix materials. What is cement? The cement which we have discussed right now, it comes to you in a bag, and then it is not a final material. Basically, you are mixing it with some aggregates. They may be coarse aggregate, fine aggregate, depending upon the application. You may be making a RMC, ready mix concrete. You may be making plaster mix, or mix for laying of your bricks or blocks. So those all require mixing of my cement with some other material. So when you were doing that mixing, basically, as a civil engineer, I will tell you that the biggest challenge for a civil engineer is that the work being executed at the site is mostly being done by a layman or a laborer or an uneducated person. So whatever best design you give him, ultimately he is not so educated. So we have tried to be as near to the best practices as far as possible, but still, you just imagine, we give the charge of adding water to that measure to maintain your water cement ratio. Do you think he will be able to do it? No, that's not possible in the given scenario. So that's why we have tried to mix those material at a plant level in a controlled manner, where not only the quality of the material is ensured, but also the mixing and the type of grading, everything. If you talk of aggregates, we know, all know they have to be well graded aggregates. But how do you ensure that at site? It's not possible. It can be ensured at your factory places. So that's the reason we have done all this, and we have come up with this product. Now, what are the basic ingredients, you can say, which we are adding in it? These are cement, different sizes of aggregates. It can be coarse and fine depending upon the application, stone powders, and these are various chemicals with different applications which we normally add into our mix depending upon the requirement. They can be hydrophobic agent, they can be air entraining agents, they can be water retaining agents. So different type of thing for different applications. And since this is a factory made material, quality is assured. You will save on time and money also using these products. So once I go in detail regarding the market of these products, it's highly, you can say, growing with exponential growth. And in the coming times, you will find that cement will be having a very limited use. You all will be using these specific value-added cement-based products for your construction. So basically, what are the challenges over here is supply chain management, where I need all these things in time with good quality. Customer demands, customer demographics, what is his requirement, what is the volume requirement, that we have to take in care. Then there are political scenarios, legal requirements that we have to take care while coming up with this product. And of course, our sustainability in terms of environment and technology. So that is all we have to see before I come into this. Now, dry mix mortar, as I have told you, that if we talk of US, the growth was around, in these 4 years, the market has grown by 24.5%. It is not as much, this much in India, of course, but in the coming time, it will grow like anything. Now, what are the advantages? They give us thermal insulation. They are eco-friendly. They help in improvement of industrial structure. Testing of each and every product is ensured because technically we are making it in-house. So that is it. They are very easy to use. This is very important. As I have told you, your mason is not educated. He doesn't know how to use the product. Here, if you talk of concrete, normal, simple concrete only, and there are 4 ingredients in that normally. So if you talk to him and ask him to have a proper proportion, I am very sure it is not possible in today's scenario. So that's the reason we need all this. And these all have good water resistance properties. That's a major challenge in all buildings. Now, these all have better flexibility, minimum space is required. If you are ordering aggregates for your site, you need a lot of space to place those aggregates. Normally, they are laying in open, so that challenge is also met. They have good compressive and flexural strengths. Inventory cost is saved, and your mixing and stirring and mechanical mixers, whatever you are using at site, those all are done with, and you don't require them. Now, coming to the ingredients of these products, basically, friends, all these products, you can say these are the three major things which are there in each of the product. It can be cement, some aggregates. I have written the word river sand, whereas it can be any other sand also, or some aggregate coarse as well as fine, and then some additives. Now, these additives play a very important role. As I have written, they are ethyl cellulose. Basically, they different type of additives are required for different type of material. We'll discuss in detail. Now, raw materials, binder as a, now it is not only cement, it can be gypsum powder also. In some of the product, we are using binder as gypsum powder as your binder. Then we have RDP, that is dispersible powder, basically for proper dispersion of your mix. And then we have some water retaining agent. These are basically ethyl cellulose. And then we have some hydrophobic agents which are added. These are zinc stearate, aluminum stearate. Then if we need be require, we add some air entraining agents also. So these are the basic components which we are using. Not going in detail, cement, you all know, sand is, it has to be properly graded. We use it. And then admixtures, you all know, using these admixtures, I can have this kind of flowable mix under control. Now, there are various kind of admixtures, as I have already told. They can be accelerator or retarder even, depending upon the mix you require. We do give a mix which are used for fixing of your machine foundations. There we are adding accelerators, water repellent agent, depending upon the finishes which are for exterior of your buildings. And these are the basic things which are there in most of my products. Basically, they are dispersing agents to have good workability of your mix. Now, where we can use these products, they can be used as a plaster, they can be used as a repair material, they can be used as a tile adhesive in tile grouts. I have a tile adhesive and tile grout. These are two different material. External thermal installations and self-leveling secretes can be made under this category. Brick fixing mortar. I have written brick or block. Most of the time today, brick is being replaced with your block. We are using AC block or fly ash bricks. Friends, if you are using fly ash bricks or AC blocks, you need not go in for your traditional cement mortar to fix those, because the whole thing is gone. If you are again wetting your blocks, that is not recommended. You have to use material which doesn't require curing. So special block fixing mortar is available from many companies that has to be used for fixing of your blocks. Cementitious waterproofing compounds, sucrose, and epoxy grouts, skim coats, these all are various dry mix mortars. Advantage, I have told you many, easy to mix, better flexibility, you will save on time, you will save on inventory, you will save on curing cost. That is very important. Most of these products which I will introduce you today, they don't require any curing. We have added some chemicals into it which retain the water in the mix, and you don't require curing after hardening. Now, basically, what are the need of these value-added cement-based product? These were the four basic needs which pushed us to launch all these products. Basically, we need to save on time. We need to have products which are durable. We need to have ease in application. When I say ease in application, it means the product should be such that it can be applied by even a layman in Indian scenario. And there should be value for money. Whatever we are giving to our customer, he should get a good product against that. So keeping all these four in mind, we have made this basket of our entire value-added cement-based product, which I will be discussing with all of you today. Basically, this is the core material which is being used as a raw material, you can say now, in all of these products. We were the first to produce white cement in India, and today we are the world leader in this white cement as well as wall packs. Now, one line definition of all of this, and then, as I have told you, I will give you a description in 3 slides. First is description, second is a technical discussion. If you want to know anything technical, that will be technical parameters will be shared with you, and then the costing for all these products. So you will get a good insight of all these new products. Some of them are quite, say, 8 to 10 years old also, but most of them are new in our basket. So this was one of the oldest product in my market. This we started in 1984. This is nothing but a skim coat. Once you have done plaster on your walls, see friends, plaster is required to level the surface. But if you want to further smoothen the surface for painting purposes and for aesthetic purposes, you need to further apply something over your plastered surface to have good, smooth, silky finish. Now, this is a white cement based skim coat. We call it as normally painters and masons, and in market, this is very well known as wall putty. So JK, we are world leader in this product. Not only India, we are exporting in other countries also, but under umbrella branding, as I have told, now the product has been renamed as wall bags. So this is the first product I will take up. And now next is shield bags. What this is, we have worked on some waterproofing properties of this product. We were, over a period of time, we have seen that when this product was being applied in exteriors specifically, there was some problem of cracking, flaking of paint, of which is of course applied on this. So to take care of that, we have worked on its waterproofing properties, whiteness, and coverage. These are the 3 enhanced properties of shield bags over wall bags. So these are 2 skim coats. Now this is a very one of my favorite products, friend. This is a direct substitute of your plaster, JK Level Max. This is traditionally you have been, as I have told you, you have been doing plaster with your cement, sand, mortar. You mix it at site only. That is again done by a labor. So to have a consistent quality, this you can say is a ready mix mortar, ready mix plaster mix, and this is white cement based. And normally we recommend it for your blocks where you have done block work or fly ash bricks. Why I'm not recommending for clay brick is that in clay brick the undulations are very high, so that won't be a viable situation for you, because this is a bit costlier product, and normally we recommend it for your blocks only. Now this is my white cement based primer, JK Primex. Friends, after plastering, normally if you don't want to apply any skim coat, you don't want to have very smooth walls, you just want to paint it. Even for that, you require a primer. Primer is basically a priming coat which is applied onto your walls. Normally, till date, that primer was from any paint manufacturing company, and that was a acrylic primer. That was a chemical-based acrylic primer, which was just giving a sort of, you can say, lamination over your wall as a base. Whereas this is a cement-based primer which has a good bonding with your base, over which you can apply any kind of paint. So this is new. Then this is the entire range of my tile adhesives, which I have already talked about, Tile Max, as the name suggests. Now these are my 2 gypsum-based products. This is Gypsomax, and this is basically, you can say, a substitute of normal POP, which we say in market, but with a very high quality we have launched. And this is with some fillers. Now, why do we add fillers? This is Plastomax, basically to have lightweight, because if we have to apply in a higher thickness, the weight will go on the higher side, and to have some thermal and fire insulation. This product is recommended. Again, this can be used as a substitute for plaster, but only for interiors, not for exteriors. And the last product which I will discuss with you is BondMax. This is, friends, nothing but your bonding agent. Suppose there is a RCC wall, you want to plaster it. And normally the practice is the mason or the labor will do hacking over it because it won't be having a direct adhesion with your plaster. So for that, we have given a ready to use product under the name of Bond Max. This is in liquid shape. You just have to apply it with the help of brush or to the RCC wall. It will give you a textured surface, green in color, and it dries very fast. You will save on time. And over that textured surface, which is as good as hacking, you can do any kind of plaster, gypsum plaster or normal traditional plaster, even level wax. So these are the products, friends, which I will be discussing. This is the same thing, one line definition of each of the product. Now, Wallmax, as I have told you, this is the basic product which we first introduced in 1984. So basically, friend, this is a skim coat over your plastered wall to make it further smooth. Now, the features are smooth and fine powder, good tensile adhesion, self-curing. This is very important. So although most of my products are cement based, but they don't require any curing. The reason is that we have added some chemicals, into it, which take care of water retention, and water is retained in the mix even after it gets set, and that takes up care of my curing. And it is damp resistance. It will give you good long life to your paint and resist flaking. How it is formulated? Basically, it is white cement with some polymers and some fillers. So these are the three things. The better is the quality of polymer, more will be the flexibility. Now, these are the technical specifications, friend, of this product. Whiteness is around 92%, very high whiteness. Why we have kept it? Because it is not only acting as a smoothing agent, it will also hide the base. Your base wall is plastered surface, which is blackish or grayish in color. To hide that, we have kept the whiteness very high. Fineness is high to take care of those minute pores in your plaster. It will go into those pores and try to seal them to give you a good finish. Bulk density is 1.01. Setting time is kept at a level where you can apply the material after addition of water in a comfortable manner. And these are the test tensile adhesion. It refers to how good adhesion it has with the base surface, and the compressive strength is 6 MPa, good enough. It is more than your normal plaster, whereas this is only a skim coat. So we are giving you a combination of superior strength and quality. Now, how to apply? Very easy to apply this product. You just have to add water in the proportion of 35 to 40%. This is coming in powder form. Add water into it, mix it. This is very important for each of my product. After addition of water, you should leave that material for around 4 to 5 minutes before application. Why it is so? Because that is the gestation time for your polymers to get activated. So those polymers will be activated, and they will give you better coverage as well as better tensile strength. And pot life of this product is 2 to 3 hours. Once you have mixed the material, it has to be consumed within this time. And normally we apply it in 2 coats, very easy to apply. And the average thickness of 2 coats is 1.5 to 2 mm. This is white in color. If required, you can add any standard. Regarding costing, this is very important because engineers normally restrict up to quality. Here I have gone a step further to let you know the costing also. It's a simple mathematical calculation. For each of my product, you will get this kind of slide. So this is nothing. This is per bag cost of my product, approximate 450 rupees. And we have applied it on 100 square feet area, and it is just a mathematical calculation. The only thing we should keep in mind is that here the material cost is roughly 2 rupees square feet, and 2 rupees 50 paisa is what the labor which I have taken, and the overall cost is 4 rupees and 50 paisa. This we must know while we are recommending any product at any project. We should have idea of this thing, and I will refer this thing in further slide also. Now, to talk of application, many slides I can show you where this product has been used. As I have told, we are world leader in this product. So now this has been specified in schedule of CP. This is extract from CPWD schedule of rate. CPWD is a central government authority for construction of government buildings. They normally follow CPWD schedule of rate. So in that also at 30.80, they have written this product as white cement based putty with the average thickness. They can't write a brand name because they have to be neutral. And there they have calculated in detail, and their costing is 115 rupees and 50 paisa per square meter. And they have included, because it is a bit higher than what I told you, the reason is they have even included the GST, water charges, wastage, everything. So it's a very detailed thing, even the margin of contractor. Now the next product is Shield Max. This is, as I've told you initially, this is an enhanced version of your Ball Max, where we have added this sealant now to improve its waterproofing properties. This is SiH4 molecules. These are basically silicon molecules, and they form a very highly integrated gel in this material once you add water. And that integrated gel won't allow water to penetrate through it. So that's the beauty of this product, that it will be to a larger extent, you can say it is a waterproofing material, moisture resistance, low water absorption, efflorescence normally comes with water only. So if I have taken care of water, efflorescence won't be there. Multi-purpose application. It resists dampness. It has good water repellency, longer paint life, and it is ideal for both new and old surfaces. Now this is, friends, it's technical specifications. Here, no, this is basically a comparison between your one. This is my product, JK Shield Max, and other products which are available in market. Just to say that we are better in quality in each of my parameter, you can say we are better even in water absorption. We are on lower side with others. Water penetration is lower than others. Coverage is higher than others. So that makes us a brand leader. Now, as far as technical specifications are concerned, these are the same. White is the color. We need to add 38% water to make a paste. Now, these are two new tests for this cast and tube test. Basically, this tells you the water absorption of any material. We make a layer of this material, put a cast and tube over it, put water into it, and measure its absorption. So it is 0.3, which is very much below the required standards. So it's a good enough. Compressive strength is again 6 MPa, and coverage you can see it's not only waterproofing property on which we have worked, we have increased the coverage also. Just to share with you, for Wallmax, the coverage is around 14 square feet per kg in 2 coats, whereas in this it is 21 square feet per. So almost 50% increase in the coverage. How to apply? Very easy. You just have to clean the surface, make the paste, do some repair work, and you can apply it. Now these are the various tools which are used to apply. Very simple things. Surface preparation, you just need. Actually, friends, this product should have direct contact with the cementitious surface. So anything in between, it can be dirt, grease, old painted surface, that has to be removed. Only then you should apply this product. This is how we make the paste. This is a mechanical stirrer being used. 38% water we have added. And once you have made this material, it has to be used within 1.5 hours. This is how we apply this material. It can be with the help of this thing or a putty blade. Now, what are the 4 major advantages of using Shield Max over Wall Max? Is damp resistance, efflorescence resistance, longer paint life, and this is suitable for all kind of. When I say all kind of wall, means exterior, interior, both. And now, friends, this is regarding costing of this product. Here you can see in Wallmax, if you remember, the rate of per bag, which is of 20 kg here also, there also. So it was 450 rupees. Now it is 900 rupees. Now the rate of bag has gone. There's a 100% increase in rate of bag. But if you see square feet costing, it has increased only by 10%. Why it is so? Because coverage has also increased over Wallmax. That was 4 rupees and 50 paisa square feet. This is 4 rupees and 80 paisa square feet, roughly 10% increase, you can say. This is a simple mathematical calculation. So what I am highlighting over here is spending 10% extra on your skim coat expenses. You can have a waterproofing effect also and better whiteness for interior as well as exterior. This is applied sample, of course. This is in wet condition. After drying, it will give you a good white finish. Now, friends, the next product is Level Max. I hope you all are jotting down the queries, whatever you want to ask, that I will take up in the end of session. So this is a product, friends, which we call as Ready Mix Plaster. As I have already introduced, this is a replacement of your traditional plaster on blocks, fly ash, bricks, hollow blocks. For all those even RCC surfaces, you can directly go in for plastering with this product. You just need to add water into it. Nothing else is to be added. And this is white cement based. Here I have written 4 to 6 mm. We have modified this product and now we can go up to 12, rather 18 mm also I have tried. And that is a more than sufficient thickness for your these kind of surfaces, that is blocks. And what are the features? Thin layer plaster for smooth surfaces, self curing. That is the very great advantage of this product. Have you ever seen, most of you must have experienced that while doing plastering, there's a lot of chaos at the site in terms of curing. We have to do pre-wetting, pre-curing, you can say. Then after application of plaster, another 5-4 days, you have to do curing, rather 10 days, to have good sound strength of your plaster, which all is done away once you are using JK Level Max. Just mixes with water, no pre-wetting required, no post-curing required. Apply it and within 24 hours, you can go for painting or anything, whatever is required. No shrinkage cracks will be there. Single coat plaster, save on water, labor, no choking of paint, strong internal adhesion. So these are the features. Application, as I've told you, many areas, even leveling of your old plastered surface. Suppose some old plastered surface is there, there's a lot of undulations on that, which you can not do with your normal skim coat. There you can apply this product as a leveling material, ideal for removing roughness of sand, cement, plaster. Concrete rendered walls. This is an important application. I will show you a good project which we have done for RCC walls. Over RCC walls, directly they have applied this thing. Hollow blocks, AAC blocks, precast wall, concrete walls. All these are the areas of application of my JK Level Max. Now, as far as application plans, very easy to apply. You just need to add water. It is to the tune of 25 to 28% surface permeation. As I've told, nothing should come in between the surface and a product. It should be free from dirt, grease, oil. And once you have done that, add 25 to 28% water, wait for another 5 minutes gestation period of my polymers, and then you can apply it with the help of normal tools which we use for plastering. And you can go up to a thickness of 10 to 12 mm. Even beyond that is possible with this product, depending on the requirement. Now, if you talk of technical specifications, here the whiteness has gone down. In previous two products, the whiteness was high. Here it has gone down. Why? Because I have added some filler also. This is not pure white cement. There are some fillers also. Naturally, they will bring down the whiteness, but that won't affect the requirement because it is a plaster coat only. You have to put a skim coat or a paint over it afterwards. So bulk density is 1.48, pot life is 160, water retentivity is very high. When I say high water retentivity, it means it will be acting as a good waterproofing membrane also. That won't allow water to penetrate through it. So if it won't allow water to penetrate, that means this can be used both at interiors as well as exteriors. You can see the strength. If you compare it with normal plaster, it is normally plaster has a strength of 3 MPa maximum, whereas we are giving more than 5 MPa. Talking of costing, here the bag is 320 rupees. It's a simple calculation we have done from 100 mm in a coat, and it's applied in 2 coats inclusive of labor, everything. Material cost is roughly 8 rupees. Labor cost is roughly 10 rupees. Overall cost is 18 rupees. Now this is very much comparable with your traditional plaster. Traditional plaster you have been doing at almost the same rate. So the only thing is awareness about the product. So where you have saved, you will say the money is almost the same or a little higher, you can say. But where you have saved on curing cost, you have saved on time, no curing, no time, extra time. You have saved on labor. You have saved on the neatness of your site. So here I will show you some photographs of this product. This is a sample applied on blocks. See how neatly they have done. Otherwise, is wall pay. If you want to go in for plaster, they will do curing, then they will do a number of things. So it's very easy to apply. Now, this is the perfect example of application of this product. This is HPCL refinery Bathinda. This is HPCL refinery Bathinda, where they have done all the walls with this level backs, and this level backs. These are all RCC walls. You can see the section of these walls. These are very thin walls. These are not brick or fly ash walls. These are your RCC walls, and over that they have applied my product, and then they have done this texture coating, both on an interior and exterior. And many projects we have done. Again, this product has also been specified in your schedule of rate of CPWD. Here they have defined as 6 mm plaster on cement concrete RCC work with white cement based polymer modified self covering. They have included all the properties. They can't write the name. So this is it, and their costing is 205 rupees and 50 paisa. If you compare it with traditional plaster, there are n number of advantages of my product over them. First, strength will be higher. Gypsum plaster, if you compare, naturally this is a sulfate based, very low in compressive strength. Traditional plaster, it's a variable strength because it is in the hand of labor. It can be applied both on exterior and interior. This we can't apply on exterior because this is POP exterior. It is not a good friend of water. This, of course, we are doing both sides. Antifungal properties are there. Here also, we don't have any antifungal properties. If you go in for my level max, this is my level max or coarse wall putty, same thing. We save on the cost of our skim coat also. A single coat of skim coat will do on this product, whereas we require 2 coats of skim coat in traditional plasters. It will be, of course, more durable because it is cement based. Primer is not required for further painting. Reduction in cost of time and manpower. You will save on water, and it goes with your green building concept, as we are saving on water. Wastage is almost nil, no curing is required. So these are all the advantages. Now next take up is JK Primex, friends. This is a substitute of your primer. If you want to paint any cementitious surface, as an engineer, you know, whenever you want to do painting on any of the surface, we have to apply a primer. So for cementitious surfaces, till date, we are getting acrylic primer from paint companies. What they were doing were, they were like, this is your plastered surface. They were just, no, this is the microscopic view of that plastered surface. There are a lot of pores in it. But if you go in for acrylic primer, what it is doing is, it is just equivalent to putting a polythene sheet over it. Just imagine that you have put a polythene sheet over it. What will happen? It will become smooth. You can apply paint over that polythene sheet, but these holes are still there. What will happen after a certain time? That polythene sheet will get torn and everything will be gone. Whereas in my product, it will actually move into this, because it is cement based, it will have good adhesion with all these pores. It will actually move into these pores. It will make the surface more smooth and better adhesion with your paint. See, just wait. Sorry. Now this is your plaster surface. This is your normal paint-based primer, and this is my product. You can very well see the difference. It has sealed all the pores. It will give you better whiteness. So this is always a better substitute. It is breathable. That is a basic requirement for any primer. And if you talk of the specifications, very high on whiteness. Why we have given high whiteness? Again, it has to hide the base. So whiteness is very high. Fineness is also very high, because we have to, you know, this should actually move into the pores, as I have explained, of your plastered surface. So fineness is kept high. Bulk density is low because it's a fine material. Viscosity is this much, and it has got a very good coverage, 96 to 100 square feet per kg. It comes in powder form. You just need to add water. You just need to add water in it. 1:1 is the proportion. One part of powder JK Primex and one part of water, and you can apply it with the help of brush or a roller. Now talking of costing, it is coming in a bucket of 10 kg. In that 10 kg, we have two pouches of 5 kg each. The costing of that bucket is normally 950 rupees. And this is how we have worked out the entire thing. And here the material cost for two coats is 2 rupees, and labor cost, since it is just a simple brush application, 1 rupees and 50 paisa. Overall cost is 3 rupees and 50 paisa. So this is it, and this is very much comparable with your acrylic primer, but with better quality. Now, if you compare it with traditional lime wash, this can very well replace your lime wash. There are many areas, friends, today also, specifically in rural areas, even in urban areas, where we are using lime wash. It can be your basement area, parking area, boundary walls. So there, instead of lime wash, you can directly use Primex. You can add any stainer into it, and it can be applied. It can give you any color also, and the advantages are immense. You can see it lasts very for a very short period. It has a long life. It has got better flexibility because of polymers, and it has got high reflectance even. So all these will make it a good finish. See the whiteness of this product. These are the actual photographs. We have even recommended, here it is being replaced of lime. This coating or cup painting we were doing with lime. You can very well do it with this thing. This is in Chandigarh. We have got the approvals. Many projects we have done. Another advantage of this product, friend, is that this can be applied on wet plaster. This is the only product which can be. What I mean to say over here is, since this will seal the pores of all the plastered wall, the water which we have used for making the mix of this plaster will be retained for a longer period, and we don't need any further curing. This plaster will get full strength, and where you are saving is using the same scaffolding. You have applied a coat of Primex also over the plaster being done. You can see plaster has been done only till here, and they have applied a coat. Same way, scaffolding has been shifted, and they have done it. Entire building. So by the time you have done the plaster of this building, the one coat of your primer has also been done to protect your plaster also. Many areas we have done. This is just running through. It can be done in any color also. Here they wanted to put some glass panels over it, so they have added blue stainer. So this is it. Just running fast so that we can come to the. It is here. It is being applied with the help of roller. Any projects. So see, this is the bucket, 10 kg bucket, which has got two packs. These are many projects we have done with this. Now, next product is Gypsum Max, friends. Gypsum Max is nothing but a gypsum-based plaster, and this is basically in two forms we are giving. The first one is Gypsum Max, which is a normal replacement of your PVP. The whole story revolves around the purity of this product. There are many brands available in market, but there are very few who are conscious about the quality and purity. We have given very high whiteness that is only possible because of high purity, and we are giving smooth silky finish. No curing is required. This is for exterior, for interiors only. You should not apply this product for exterior, not a good brand of water. This is how we apply it, and see the whiteness. Specifications: it water demand is 70 to 75%. Fineness is 0.3. Setting time is around 22 minutes. The higher the setting time of this product, better it is. The reason is that the applicator wants some time to apply this product. This gets set fast, very, very fast. So they need some extra time in which it should remain in plastic stage. So we have tried to give that. And the transfer strength is around 5 minutes, 5 MPa, sorry. And if you talk of costing, again 25 kg bags is of 280 rupees. It is around 21, 22 rupees. 22 rupees is the cost per square feet. Again, very much comparable with your traditional plaster. Out of which 10 rupees is the labor and almost 12 rupees is your material cost. Many buildings we have done. Now, friends, this is an enhanced version of your traditional gypsum plaster. We call it as one coat gypsum plaster. Why one coat? Because if you want to have a thicker, more thickness, normally POP was being applied in two coats. If the thickness is more than say 15 mm, but with this material you can go beyond 20 mm in a single coat, because we have added some material in this that is perlite base, which makes not only vermiculite base, basically that increases the thickness also, plus some other features also. It will make it fire resistant, thermal resistant, and it, since it is a one coat, it will reduce the time of construction also. The whole plaster you will be able to do in single coat. As far as specifications are concerned, they are almost the same as Gypsum X. Water demand is the same, fineness is the same. It's almost the same. Workability time will be more. It will remain in plastic stage for 2 more minutes, and the transfer strength is the same. If you talk of costing, since I have added something in it to give you more properties, the costing has further increased to 28 rupees. In that case, it was 22 rupees. Here it is 28 rupees. Application cost is same 10 rupees. Material cost has increased by to almost 19 rupees. So this is regarding Plastomax. This has got good fire resistance also. So this is a substitute, but again the limitation is that this can be applied only in interiors, not exteriors. Now, friend, this is a product, BondMax, as I've told you, this is a bonding agent. If you want to do plaster on your RCC surface, any RCC surface, you have to do hacking on it, because plaster will not have good bonding with the smooth RCC work. While doing RCC work, every engineer wants that it should be as smooth as possible. But the problem comes when we do try to do plaster over it. So we have to do hacking. So we have given a solution, because if you are doing hacking, you are actually playing with the strength of that concrete wall. So we have given a ready mix material under the brand of JK Bond Max. This is in liquid form. You can apply it with the help of roller or a brush onto the surface. It has got some coarse material in it. That coarse material will give you a textured green color finish. And it has got very good mechanical and chemical bonding with the surface. And you can see its drying time is only 6 hours. Once you have applied this, after 6 hours, you can go in for plaster. So here, as I've told you, we have worked on various parameters. Here, what we are saving is time. So hacking cost is almost, you can say, the same as of my this product, but that is a very time consuming exercise. Whereas in this you can save on time, and quality also will be ensured, because hacking again that will be done by a layman labor. It won't be a uniform thing, whereas this is a very uniform textured finish you will get. And material cost here, it is roughly 3 rupees, 2 rupees and 67 paisa, and application is 1 rupees and 25 paisa. Overall cost is 4 rupees. In 4 rupees you have done the square feet, you have done this thing. Sorry, other than this value for money, you will save on time using this product. Now, friends, the last range of product which I would like to actually, this was the product from where I started also. So this is TileMax, tile adhesive. Basically, I have started my discussion. I have opened the discussion with this product only, that you not use the same cement for fixing of your tiles as you have been using for your other works, because this cement doesn't get an opportunity to get cured. So we have formulated something for you which doesn't require curing. This is a self-curing mortar which can be very well used for fixing of tiles. And once you have put the tile, since it doesn't require any curing, there won't be any shrinkage, and no curing required. Since there won't be any shrinkage, there will be no issue of delamination of tiles, which normally happens in your normal cement. And it has got some waterproofing qualities also, which will help you when you are fixing tiles, specifically in water prone areas, that is your bathrooms or your water these kitchens or swimming pools, whatever. Now, benefits are, this is again a powder. You just need to add water, easy to apply, suitable for all kind of wall, no sag resistance, high sag resistance, sorry. Basically, we have launched this product in 3 variants, friends. as per IS 15477. This is the IS specifications of this material. They have given two types, type 1 and type 2. Recently, they have revised the code. Even the types have been revised till type 5. But right now, we are giving type 1 and type 2 only. In type 1, we have this product, Tilemax 111, which is basically type 1 gray cement based. Then this is Tilemax 222, which is gray cement based again, but with a higher bonding strength. This is for large format tiles. This is how they have defined type 1 and type 2. Type 1 is for the tiles having porosity more than 3%. That is normally your ceramic tiles. And type 2 is for having porosity less than 3%. That is your vitrified tiles, marbles, granites. So for normal ceramic tile, I will recommend this product. And for those kind of surfaces which are non-porous, that we will recommend this one. And if you have a large format tile for exteriors, today people are using tile of size of 8 feet by 4 feet for exteriors. So for that things, we have white cement based adhesive also. This is for exterior surfaces. These are the basic features, very easy to apply. I'm not going in detail. Water resistance is there. Their quality increases from here to here. The moment you move from here to here, you will get a better bonding strength. Here to here, you will get waterproofing effect also. So basically, this is for normal applications, interior of your structure, exterior of your structure, high waterborne areas. Sorry. Same thing. This is for fall and floor. This is for premium multipurpose applications. Now, these are the technical specifications. Friends, running a bit fast because we have already taken more than the time given to me. So basically here, two things I would like to tell you: open time and adjustability time with respect to tile adhesive. What is open time and what is adjustability time? See, friends, first thing is that this adhesive is to replace only the material which we were using to fix the tile, only the pasting material. So the thickness of this material is normally in mm, 3 to 4 mm, 5 mm, 6 mm, depending upon the thickness of your tile. So we normally apply this material onto the base substrate and then put tiles over it. Once you have applied that material on the substrate, this open time refers to the time within which you can put those tile over that applied material. And this adjustability time is the time in which you can further adjust those tiles. Normally, if you have seen people fixing tiles, they adjust the tiles slightly after putting them in place. So that adjustability time is around, so total of this thing is around 45 minutes. So around 45 minutes after applying on wall is available for you to fix the tile, to properly adjust the tile also. And this is the tensile adhesion. We are very high on tensile adhesion because this is the only property which we look for in tile adhesive: how bad, how good it holds your tile. And these are the shear bond adhesion results in dry and wet conditions, both we have done. And these are the test results. We are much above what is required. This is regarding type 1. This is regarding type 2. Of course, the parameters have gone up in type 2 and our values have also. And this is type 2 white, the highermost range. And this is regarding costing, friends. Same mathematical calculation. This bag is around 250 rupees. This is type 2 gray, which is 470 rupees. This is 15 rupees square feet. This is around 19 rupees square feet. Here we have taken the thickness at 2.5 mm, rather 3 mm rather. In all the cases, if you maintain the thickness at 3 mm, the costing will be this much. Then we have some grouts also, friends. This is epoxy grout and cementitious grout, both we are into it. And these are the material which are used to fill the gaps between the tiles. Earlier we were using cement only. So these materials, this is how we calculate the requirement. This is length of your tile. This is width of your tile. This is thickness of your tile, depth of the joint. And that's how we will get how much quantity of material is required to fill the grouts. This is how we apply the material. I have gone a bit fast in the end so that we can complete the things within the given time. I think I started at 11:15. I have taken around 45 minutes, 50 minutes, which was given to me. And these are the various approvals which were with us. Thank you, friends. That was all regarding these value-added products. My suggestion to all of you is that you should keep yourself abreast with the new technology products which are coming in the market while you are in academics or whatever field you are working, so that whatever you make in your coming days, whatever structures you make, you always are able to deliver quality to your clients. With that, I would request Saurabhji to have any question if it is there.
Thank you, sir. Thank you so much. That was and indeed a very interesting session, because as academicians and researchers, we were exposed to how things are being executed in the field, and how the practitioners are using the products, and what are the products which are available for us also in order to use for our studies and from a research point of view. So that was really interesting and insightful. Sir, there are certain questions which I would like to convey to you. There is a question by Mr. Rajiv Chauhan. He states that JK Cement won the contract for proposed Mumbai and the Ahmedabad bullet train track.
Yeah, yeah. It is a
So
very recent.
recent, yeah. So what were the strengths which made you got that contract above all the other competitors?
May I know the person who has asked the question?
It is by Mr. Rajiv Chauhan.
Yeah, Rajiv ji, first of all, I'm glad that you are so much aware about our products and our achievements. Actually, as I have told you, we are very conscious about quality, and we never compromise. Whatever the case may be, we go up to the extent that we are ready to lose the order, but we won't compromise on the quality. So that is our concept. And as you know, that metro project, they are highly quality conscious. So it was nothing, only the quality which helped us to win the order. There were many brands. As you know, the project is very prestigious, and they have gone in for thorough testing. And we were among the top three. And further on that, when they negotiated on cost, also being very honest to you, we were lowest in all those three. That is a commercial aspect we have to take care. So because we wanted to have this project in our fold, since it is very prestigious, so that's the reason. The first and the foremost is quality. Rate is secondary. We are flexible for such kind of projects, but quality we never compromise.
Thank you, sir. I would like to correct myself. That was Dr. Rajiv Chauhan. He's a professor in Punjab Technical University, sir.
Yeah, Rajiv ji. Thank you.
There is one more question from Mr. Manoj Kumar Punia. He's asking about is JK Cement launching a water-resistant product which can be used in concrete or plastering works?
Yeah, that I have already introduced to you. My product, if you were listening thoroughly, JK Level Max is the product which can replace your plaster. And this has got very high water retentivity. I won't use the word waterproof. If you ask me, I have worked with waterproofing companies also. Initially, I started with those companies also. I was the person to launch Dr. Fixit in this area at that time. It was in 98, 99. So my experience over whatever experience I have in this small time which I have worked in the field, there is nothing which can be waterproof.
Okay.
Believe me, there can be nothing which is waterproof in cement industry, because it can be water resistant to some extent. So if you talk of water resistance, water repellency, it is very high in my JK level max. You can very well use it as a substitute of your plaster, both for exteriors and interiors. And since it is a white cement based product, I would request you that limit its application only for blocks. If you go in for, it can be done on clay bricks also, but if you want to do it on clay bricks, since the thickness will be high, you won't be able to achieve your economy. So I am very conscious on costing also. So I always recommend the right product at right place. So if it is your AAC block, hollow block, RCC wall, go for it. Do let us know if you have any project. We can do samples for you wherever required. within India, even abroad, not an issue. So do come to us.
Okay, thank you, sir. There is another one. It states that how water soluble polymers such as HPMC interact with OPC. What was the difference in strength and microstructural properties for polymer added mix as compared to control mix?
Very nice question. Basically, these ethyl cellulose which we are adding into your dry mix mortars, they are coming in powder form only. There are polymers which are in liquid shape also. They normally people add those at site. But since I have to give dry mix mortar, so my products are all using dry polymers. So these are dry polymers. Now what they are doing in it is the first thing is water retention. They will help to retain water, since I have already told that none of my product requires curing. So there, that is where you save on cost. So all these material will help in ethyl cellulose. They will help in retaining water which you have added in the mix for a longer period, and that nullifies the requirement of your curing. So that is the beauty of these products. Second, these, as the name itself suggests, polymer, they will add to the workability. Once you add polymer into a cementitious mix, your workability is bound to increase. It will be a more plastic material, and you will there will be a lot of ease in application, specifically for preparation of screeds and flowable concrete. These kind of materials are being used, which will give you excellent flowability and workability.
Thank you, sir. There is an interesting question by Mr. Neeraj Kumar. He wants to ask how to differentiate between original and fake JK cement products.
Great. See, friend, it's a very, I won't say, matlab, it's not out of mind or something. He must have experienced somewhere over here. There's a lot of duplicacy. There is a lot of duplicacy. And friends, just to share with you a little background, you will understand how severe the problem was. I am using the word was because we have taken care of it now. There was so much of duplicacy in my product, specifically wall putty, since we were a leader. So JK wall putty, can you imagine the year we became world leader? It was 2 years back only. We became world leader in that product, and we had the guts and the courage to change the name of the product from JK wall putty to JK wall max. This was only done to avoid duplicacy. Nobody, there were many people, there were many consultant, marketing consultants who were saying that you are taking a high risk. You are at the top of the peak and now you are going to change the name. But that was required because everybody who was behind us, he will take certainly much more time to change the name and change everything. We overnight we changed the name from JK White, JK Wall Putty to JK Wall Max. So how to check the original product is now all my products are ending with max. No other company is making such products. You want to ensure that it is a JK White product, JK Cement product. It will end with max only. This is for my white cement based range. Gray cement, I have a product name JK Super. I don't think there's any duplicacy in that.
Thank you so much, sir. Thank you for clearing out this thing. I think Mr. Neeraj has his question answered. Uh, one question, sir, I want to ask you is as a practitioner, what do you think is the area of research where academicians can get into these cement-based products? Are there certain limitations where you as practitioners cannot go and only researchers can go? Are there any gaps or any areas which require significant research?
No, there's a lot of opportunity if you explore this thing. Everything today, technology, courtesy technology, everything is available on the internet. But if you just start with the dry mix mortar and you just explore on net, you will find n number of researches being done, n number of new. There is a lot of things. People are talking of ready mix RMC. Ready mix, when I say ready mix RMC means that it will come in a bag. It is there already in some of the countries. So lot of things, how we can make it good quality. So that is the area of research. How I can have a product which doesn't require curing. How I can have a plaster which can go beyond a thickness of so much mm. So many things can be explored and those are being done. Those are in, you can say, process at industry level also. And certainly I would welcome if some academicians have this interest, they can come forward, and that will certainly help the industry.
Thank you, sir. Thank you so much. And it has really been an honor to be hosting such eminent speakers. And thank you for taking your time out from your such a busy schedule, and for enlightening us with your experience, your products, your knowledge. And once again, I thank you. And I'm really
Thank you.
grateful.
Thank you. It was my pleasure being with all of you, and I wish you a great success of this first international conference on building material. And I hope we will be in touch. And whatever kind of, I am a very passionate person for these kind of activities. And in future also, if you need any kind of support from our side, it's a knowledge sharing sessions. We are always available on any topic you want. Thank you. Thanks for the opportunity. And I would also like to thank all the listeners who have patiently listened and given queries also. I hope they must have gained a little from this, and
Definitely.
whatever they have learned, do apply into the practice. That's a place where I am looking forward to. Thank you.
Thank you. Thank you so much, sir, for your kind words and encouraging words. Now, before I close the keynote sessions, I would once again like to take this opportunity to thank our eminent speakers for such a delightful session. It was really a knowledge gaining, and the takeaway for the attendees will be a good amount of experience, data, concepts, and the exposure to the new technologies. So ICCME is honored, and I'm very grateful to host you as keynote speakers for ICCME 2021. Thank you, Professor Reddy, and thank you, Mr. Malhotra.
Thank you.
Now, I would request all the participants that they can kindly move to the technical sessions. The keynote sessions have come to an end, and you may kindly join, as the technical sessions have already started since 11:30. You can join and enjoy the technical sessions. Thank you.
Is it the same link with Sarah?
Yes, ma'am. Yes, the link is same.
Okay.
You all may kindly see in the chat box, I have shared the link of the technical sessions. You can just click the link and go to the respective technical sessions. Session 1, Session 2, Session 3 are in progress. Gayatri ma'am, if you are hearing me out, you can just go to the chat box and go to the respective links. Thank you.